we're given a function f of x at intervals where f is concave up and concave down. So we need to find the second derivative of f, and to do that we first have to find the first derivative of f. We need to use the quotient rule here, so we got low d high minus high d low. All over low squared, and go must things go. Now let's clean up the top a little bit. We distribute the 2x. Now we'll distribute negative 2x to the second quantity. See that we have some terms that eliminate each other. So we'll have negative 50x minus 18x remaining. Now that we've got the first derivative of f, we're going to go and find the second derivative of f. We're going to have to use the quotient rule again. So we'll go low, d high, minus high, d low. We use the chain rule to differentiate that denominator. We're going to get 2 times 20x squared minus 25. All raised to the first power times the derivative of the inside times 2x. Okay, all over the denominator squared. All right, so let's clean up the numerator, clean up the denominator, see what happens. Okay, for starters, whoops, you see that we're subtracting a negative up in the numerator. So we can factor out some terms. It looks like each term has at least one factor of x squared minus 25. And each term has a factor of 68 in the numerator. So let's see what we get if we factor out x squared minus 25 times 68. And to be sure, we took this minus negative up here, so we change it to plus. Okay, so what's left? Oops. What's left up top is in the numerator is 1 factor of x squared minus 25. In particular, the factor of negative 1. So let's see what we just did. We took out the factor of x squared minus 25, giving us with 1 factor of x squared minus 25. We factored out 68. giving us a factor of -1. We got plus. We factored out to 68. Factored out to x squared minus 25. So what we're left with is x times 2 times 2x. This is all over x squared minus 25, all raised to the 4th power. The quantity x squared minus 25 squared is the quantity x squared minus 25 to the 4th power. Well, it looks like we might have some eliminating that we can do. One factor of x squared minus 25 in the numerator. Eliminate one factor of x squared minus 25 in the denominator. So left with (68) times something over x squared minus 25 quantity cubed. And let's see what we can do with this guy inside. If we distribute this -1 here, we're going to get minus x squared plus 25. And we've got x times 2, which is 2x times 2x. So let's say plus 4x squared. We got some like terms. Minus x squared plus 4x squared is 3x squared. Alright, so now we have a second derivative. We can try to discuss inflection points or concavity or things like that. So let's get started here. Now we need to find some critical numbers. So let's find when f prime prime is 0. Let's find when f prime prime is undefined. Fraction is going to be 0 when the numerator is 0. Now it's just algebra time. We can divide both sides by 68. We can subtract 25 from both sides. We can divide both sides by 3. We can square root. And notice that we get an imaginary number here. And in our calculus class, we don't deal with imaginary numbers, so we get no critical numbers for setting f prime prime to 0. Now let's see when f prime prime is undefined. We'll set the denominator equal to 0. We can cube root both sides. Cube root of 0 is 0. Now we can either factor and solve or just add 25 to both sides and square root. So we get two critical numbers. Now that we have critical numbers, we can go make our sign chart and see what we find. Okay, so we just wrote as a reminder what f prime was equal to. Now we'll evaluate. Let's pick -6 for the first region to test. A -6 squared is going to be positive. Positive times 3 is positive. Positive plus 25 is positive, times 68 is positive. Negative 6 squared is positive 36 minus 25, which is going to be like 11. 11 cubed is positive. So f prime prime is positive in this first region. Now let's pick a number in the middle region, say 0. We'll get a positive in the numerator and a negative in the numerator. So f prime prime is negative in the middle region from negative 5 to 5. And finally, we'll pick a positive number like 6 for this region. So give us a positive over positive. So when it's all said and done, we can conclude that f is concave up on 2 intervals. Negative infinity to negative 5, and also from 5 to infinity. We can conclude that f is concave down on 1 interval, from negative 5 to 5. I hope this helps, makes some sense, clear things up. Thanks for watching. Have a great day.